Hey, this is my my MIDI Blink, my MIDI Lightboard as I call it. If you have been watching my channel before, you have seen this in action. I'm not going to demonstrate it now, but I will just turn the power on and connect 12 volts here and 5 here. You'll see the LED backlight come on. And this is just a very simple diagram over how it works. There's MIDI coming in at the top, and I can use the buttons to the left to browse through the different menu options and edit them, increase and decrease values. The display will show what's going on, and it will show MIDI notes being received if it's in that mode. And then there are 12 GPIO pins that will be sent directly to the GPIO outputs down to the left on the pin header, or via the NPN transistors. There's 12 of them as well, and they will sync current from whatever you connect to the pin header to the right. So that's a pretty simple description of how this works. And I have 3 buttons here to control it. When the display is in this mode, I can press this button to just test all the LEDs, which makes them all light up in a nice way like this. So I can see they're all working and being triggered. Usually in this mode as well, if I get MIDI data in here, I will show the notes on the hello cat on the display while they are being triggered. And I can, with these 2 buttons, there are 3 buttons here, with these 2 buttons I can traverse a menu which starts by turning the backlight off completely and basically just disabling the display if I'm not going to use it. Next step, I can choose an octave range. As it is now, any MIDI note that is received will be triggering the corresponding output, no matter which octave it's in. It's any C will trigger the same LED strip, this one. So it doesn't matter if it's C1 or C7 or whatever. And I can change that by pressing this one, going to the edit mode. You see the cursor starts blinking, and I can choose which octave I want to listen to. So I can limit it to only listen to octave 4 or 5 or 6 or 7 and so on. One of those or all of them. Then I press again to leave the edit mode, and I go to the next menu page, and here I can choose which MIDI channel I will be listening to, the MIDI receive channel. Right now it's in Omni, so whatever channel MIDI data is received on, it will be processed, and the corresponding output LED will trigger. Again, I can press the left button here to enable the edit mode, and I can choose any of the standard 16 MIDI channels or the Omni mode, which receives on all channels. Plus I can change the fade out time, which you may have seen in the other videos, that dictates how long it takes for the LEDs to fade out. They're all controlled using pulse width modulation, and this is just like a timer, basically, how long it takes before it goes to the next pulse width and the next intensity for the LEDs. And I'm not sure which unit this is actually, I forgot. It's a number of milliseconds between each intensity, and there are 16 intensities, and I don't remember exactly, but it goes down to 0 where you have on off instantly, and up to 1 all the way up, and I'll go backwards because it will wrap to 50, which will be a very, very slow fade out time. And the ones you've seen before in the videos have been 0, 3 and 6, and that's almost enough, I think. 50, I'm not sure why I have that, it's just long. And then next press, the menu will go back to this MIDI note display mode, where I can again press this button here, which usually sends the display into edit mode, but now it triggers the LEDs instead. It would be slightly more interesting to see if I just remove this light a bit. Yeah. I am hoping that one of these will be suitable for putting this this PCB on the display in. And I'm not very good at mechanical practical things, so this will probably be a boring challenge, I would say. I don't particularly like doing this step, but I have to finish this somehow, because I can't just leave it like this. It's just a bunch of wires now, you know. The cats will rip the cables off and it will be messy. So that will be the next step, and hopefully it won't take me another 6 months to do that. Just a little short explanation of the board, and a more clean and stable close-up than what I've been able to show before. So this is the PCB, and the main component here is the PIC 16F886 28 pin dip, and the other chip you see here is a regular 74HC595 serial to parallel, and I'm using this to control the LCD, because I ran out of GPIOs, because I was using 12 outputs. I was using some GPIO for reading buttons, and I was using some GPIO for the ICSP connector. Yeah, I know I can have dual purpose pins, but it required some electrical tricks, and I just wanted to keep it simple, so these pins are dedicated on the microcontroller, the ICSP pins. So the GPIOs, like I said before, go directly to this pin header here, or via the transistors lined around the edges here to this pin header where the LEDs are connected currently. And this is of course the pin header for the display, which is used in 4-bit mode. I have one more bit I'm using right on this one for this transistor here, and what this is for the LED backlight, the LCD backlight, sorry. So when you saw me shifting through the different menu alternatives before, what I'm doing is I'm actually just shifting data out on this one, and one of the output pins goes to this transistor, which syncs current from the LCD backlight. So that way I can toggle the backlight on and off with software. I have this is MIDI coming in. It's a standard MIDI specification input with an optocoupler here, and the output goes to the UART RX pin on the microcontroller. And of course I forgot to say that Yes, I have to make cutouts in the casing to put connectors for the outputs from the transistors, and put some connector there. I don't know if I'm gonna use some just pin header or D sub or whatever, but I am then going to have to make another not enclosure, but I need to mount these LED strips somehow. I mean, this is it's even two separate boards. Yeah, so the LED strips are hardwired to specific colors by just, you know, putting resistors on the little board here where the cables are attached. So I only need 1 or 2 LEDs lighting up at the same time. So I just decided to hardwire this, and this is my interface at the moment, and this should be replaced by a connector in the enclosure, and as well some cable that I can use when I plug this in. And according to my power supply, it should be around 150 milliamps. And this is for the microcontroller, which apparently draws 70 milliamps. And this is with the LCD backlight on. And if I turn on the LEDs, it goes up to 110 milliamps. I guess these transistors aren't very effective and or efficient, and I saturate them, and I don't know, there's probably a lot of current being consumed by the microcontroller as well.